The index of hydrogen deficiency tells us how many molecules of hydrogen we would need to add. And when we say molecules of hydrogen, by the way, I should point out that's H2 that we would need to add, so 2 hydrogen atoms. When we're given some information about the formula of a chemical species, we want to start to ascertain what its structure might be. So here's an example. Now, there's no way I would expect you to know that that is the structure of this compound, and it has lots of different isomers. This is just one possibility. But this is the beginning of the process of working out, okay, well, is it in a ring, for example, or not? So we would look at seeing how many hydrogens we would need to add to make that into a straight chain, or not necessarily straight, but a chain rather than cyclic, so something non-cyclic. And we will be seeing if we saturated it, so every possible bond could be filled with hydrogen, how many we would need. So we get this formula over here. Now, if we look at how that's derived, we can see that 2 for N for every carbon, because if we were going to make this into something non-cyclic, then of course any carbons connected like this have the potential to have 2 hydrogens each on either side. So that's why we've got our 2N here. And then of course, if it's in a chain, then we would get a hydrogen at either end. So that's this +2 here. But then if we had, say, let's change this again. Let's maybe extend that to another. Maybe we might pop an oxygen in here. It could be there, for example. And we continued our pattern then of adding our hydrogens and so on. This oxygen here, that can't accept any hydrogens, so that doesn't change, that's not going to change anything, our oxygen. So Q is not part of our equation, it's missing. So we can leave that out and pay no attention to it. If we look at a halogen, which is just denoted by X up here, our halogens, we could have, instead of a hydrogen, for example, we could have a halogen coming off here. It could be a chlorine, like in this example. So you can't add any more hydrogen in where there's already chlorine. So that's like counting up the hydrogens that already exist. So we go here, we look at both the halogens, sorry, over here, and the hydrogens that already take up the spots sort of on the carbons, if you like, and we subtract them. So any hydrogens that we've got, we subtract here. Sorry, I'm running out of colors. That's here, any existing hydrogens that are already on this compound, or also any halogens. So that's hydrogens and halogens here. They have to be subtracted because they're not available sites on the carbons to pick up more hydrogen. And then if we had, let's say, for example, instead we had perhaps a nitrogen, could be perhaps bonded to, let's say, or that could even be at the end. I'll draw it like that then. So our nitrogen here can actually accept, maybe I will put it with a carbon. Okay, so our nitrogen here can accept perhaps a hydrogen, which we may or may not already have, but it can't accept another one here. It hasn't got the same number of sites as carbon. So when we've got our nitrogen, or it could be phosphorus, because it's got 5 valence electrons, it's actually only making 3 bonds, so we actually have to add 1 for that, because one of those spots that otherwise we'd be looking to fill with a hydrogen, it can't possibly be filled. So we have to, we're subtracting all the hydrogens and halogens that are already taking spots, and then we're adding 1 back in to account for if we have something like nitrogen or phosphorus that doesn't have as many available free spots as the carbons. All right, so if we work through this example then, So we follow the formula. So to count up all our carbons, accounting for the 2 hydrogen spots on each one and the 2 hydrogen sites at either end, subtracting existing hydrogens, subtracting existing halogens, and then adding 1 in to account for the 1 spot that's missing on a nitrogen. So this one here, our formula, our IHD for this, 2 lots of 6 plus 2 minus P, remember, is our existing hydrogens. We have 9. Plus R, so do we have a nitrogen? We do, plus 1. And then subtract our halogens, and we have 2 of those. And the whole thing, because it's counting up how many hydrogen atoms, and actually we want to know how many hydrogen molecules we would need, we divide the whole thing by 2. So 2 lots of 6 is 12, plus 2 is 14, subtract 9, we have 5, plus 1 is 6, take away 2 is 4. So that has an IHD of 2. Now, if we were to rewrite what that molecule could be, if we added 2 hydrogen molecules in, so we can just look at our top number, in fact, if you want to, because we've got 2 lots of H2, that we have C6H13 now. So that's the 9 here plus the 4, or 2 lots of H2. And then our other ones remain unchanged. And that's our formula of what our possible non-cyclic compound would be. Okay, so the questions in the book then, let's go through those. If I just pop a little table here. Sorry, it's not the neatest. Okay. How many do we have? We have C6H6. We have CH3, CO. Now they've given us condensed structural formulas here, but you actually only need to find just a really simple molecular formula. You're not expected to know how that would be, could be arranged. And it's not important anyway. Okay, so they're the examples in the book that we're given. We're looking for, now we'll find the index of hydrogen deficiency by doing the calculations. So let's do that just to keep that clear from here. I'll write them in green here. So this one, we've got 2 lots of 6 hydrogens, plus the 2 extra spaces at the end, subtract the 6 hydrogens we've got there. We have no nitrogens or halogens to worry about with this one. And then the whole lot over 2. 2 lots of 6 is 12, plus 2 is 14, minus 6 is 8, over 2 is 4. So that's our index. So that means when we write our formula here, we still have 6 carbons, that doesn't change, but now we have 4 molecules of hydrogen, or we have 8 extra hydrogen atoms. And that's the 6 here, plus really this top number. Okay, so let's have a look at the next one. C, we have 1, 2, 3. So 2 lots of 3 plus 2, subtract 3, 6 hydrogens, and an oxygen that we leave because that doesn't have any available sites where hydrogen can bond. 2 lots of 3, we've got 6 plus 2 is 8, minus 6 is 2. 2 over 2 is 1. So that means we can add 1 hydrogen molecule or 2 hydrogen atoms. So our formula here is C, and we've got 1, 2, 3. So we're just going to write them together in a molecular formula. And then our hydrogens, we have our 6 plus our 2 extra, 8, and then our oxygen is still there. Next one, 2 lots of 7 carbon plus 2 minus our 16 hydrogens over 2. We have 14 and 2 is 16. Oh, have I missed one there? Sorry. Oh, I have. I just realised I've written down that question incorrectly. I thought that seems really large. Sorry. My apologies, that's my mistake. I thought, hang on a minute, we're not going to have any hydrogens missing. Let me change that. So 2 lots 7, sorry, 14 and 2, we've got 16, take away 6 is 10, so 10 over 2 is 5. So add those 10 hydrogens in. Must have been jumping the gun, knowing the answer already. That's what our answer should be there. So again, carbon and oxygen unchanged, hydrogen adding in double that IHD. This one, now we've got some halogens to mix things up. So 2 carbons, so following the first part of our formula still subtracting the 3 hydrogens that are already there, and then subtracting 1 for a halogen, the X, the chlorine that's taking the space of where a hydrogen would otherwise go. 2 times 2 is 4, plus 2 is 6, take away 3 is 3, take away 1 is 2, 2 over 2 is 1. So C2H5Cl. Getting there, sorry it's a little bit cramped here, fitting it onto a very small whiteboard. 2 plus 2 minus 9 hydrogens. Now we've got one of our nitrogens. So nitrogen, the R, in our formula we have to add it. So plus the 1 nitrogen that's there, because nitrogen has 1 less available space to fill with hydrogen. 2 times 2 is 4, plus 2 is 6. Oh, sorry. I've done it again. It's been a long day. 2 times 4 is 8, plus 2 is 10, minus 9 is 1, plus 1 is 2. 2 over 2 is 1. C4H. We will put then, sorry, we've got 11 and N. Okay, and then our last one we've got is 2 lots of 6 carbons here, 2 spaces on each, plus our 2 N's. Subtract our 12 existing hydrogens, and our oxygen we don't need to worry about. 2 lots of 6 is 12, plus 2 is 14. 14 subtract 12, we're back to 2. 2 over 2 is 1. So C6H14O6. Okay, and that has completed that question.